We have learned a lot about the allotropic forms of sulfur in our lessons on the crystalline and non-crystalline allotropes of sulfur. We've also learned how sulfur is extracted in our lesson on the Frasch process. In this lesson, you will learn some interesting physical properties of sulfur. As explained in the lessons previously mentioned, elemental sulfur exists as a yellow solid substance which can be crystalline or non-crystalline in nature. That is, it can appear to have an octahedral crystalline structure if it is rhombic sulfur, or a needle-shaped crystalline structure if it is monoclinic sulfur. It could also appear in the non-crystalline or amorphous forms such as plastic or powdered sulfur. Sulfur has a boiling point of approximately 445 degrees Celsius, while its melting point and density depends on its allotropic form. For example, rhombic sulfur has a melting point of 113 degrees Celsius, while monoclinic sulfur has a melting point of 119 degrees Celsius. Also, rhombic sulfur has a density of about 2.07 grams per cm cubed, while monoclinic sulfur has a density of about 1.96 grams per cm cubed. Sulfur is part of the nonmetals in the periodic table, so it is a poor conductor of electricity and an excellent electrical insulator. Sulfur does not dissolve in water, but will dissolve in solvents like methylbenzene. Now let's discuss what happens when sulfur is heated at different temperatures. Since the melting point of sulfur ranges from 113 degrees Celsius to 119 degrees Celsius, it will melt to form an amber-colored liquid when heated at temperatures within this range. However, something interesting and unusual starts to happen when the heating continues and the temperature rises to 160 degrees Celsius and 200 degrees Celsius. As the temperature rises, the color of molten sulfur gets darker at 160 degrees Celsius. The viscosity of molten sulfur also increases at this temperature. In fact, as heating continues, the viscosity continues to increase until the maximum viscosity is attained at 200 degrees Celsius. Now let's try to understand what happens as sulfur melts and becomes more viscous. Solid sulfur melts and becomes viscous on heating because the 8 sulfur atoms in the molecule of sulfur, which are covalently held together in a crown ring structure, vibrate until they break up to form a zigzag chain-like structure at 160 degrees Celsius. The heated sulfur sample in the boiling tube reaches its maximum viscosity when all the S8 ring structures open up and the chains get entangled with each other at 200 degrees Celsius. Now let's do a summary of what we have learned so far to conclude this lesson. Sulfur is a yellow crystalline or non-crystalline solid. It has a boiling point of 445 degrees Celsius. Rhombic sulfur has a melting point of 113 degrees Celsius, while monoclinic sulfur has a melting point of 119 degrees Celsius. Rhombic sulfur has a density of about 2.07 grams per cm cubed, while monoclinic sulfur has a density of about 1.96 grams per cm cubed. The viscosity of sulfur increases when melted until it reaches its maximum value at 200 degrees Celsius. This is where we will stop this lesson. I hope to see you again in the next one.